Okay, back to the GE. If you recall, I was having some sync issues. I referred to the writers where it talked about the sync circuit. Here's a simplified version of it. I decided I'd zero in on this cap here. Looks like a real good candidate for leakage because you have B plus here on this cap. Any kind of problem with this, any kind of leakage here is going to totally whack this out and screw up the sync. Sync circuits are particularly sensitive to voltages. They usually have a pretty large value resistor in the cathode circuit, causing the tube to be cut off, except for the strongest part of the sync pulse, which is what this thing basically does. Or sometimes you'll see they have very low B plus. A lot of times the B plus also is a very large value resistor here. So you basically have the way it basically works. It takes a tube, biases it to cut off, except for the very strongest part of the sync of the signal, which is the sync part. If you ever take a look at a composite video, the video action is down here, and then boom, the sync jumps way up. Well, so basically this tube is cut off until it hits that very high sync pulse, conducts. When it conducts, that's what comes through, and you just get a single pulse, and it's cut off the rest of the time. Anyway, I decided I'd look at this capacitor C42. And here is the little offender right here installed in my old school cap tester. Getting back to checking caps, again, you really can't use these types of testers. They just won't test it properly. I mean, they can test pretty good for capacity, but they do not check for leakage at rated voltages. I could have used a scope and probably narrowed this down as well, but I didn't have my scope handy, and I decided I'd just take a shot at that cap. So I went ahead and took it out of the circuit, and it's only a 100 PF cap. You really need to take it out of the circuit to get a good, reliable test, because when they're that low a value in PFs, you can get all kinds of weird, wacky readings when it's connected, even with one leg lifted in the circuit. So I took it out and I tested it for value first. It's 100 PF, so that would be in that range. You adjust till the eye closes. All right, it kind of reacts pretty well. I mean, you get a decent eye closing right around 100 PF, so that's good. It makes sense. I mean, it was working. It was just having kind of an intermittent loss of sync. I don't know what the rated value is on this thing. I think that plate value at that phase inverter here, if I remember right, was right around 100 something volts, 150 volts, so, or 100 volts. So it's not real high, but most of these Micas are rated for right around 500 volts. And it wasn't marked, and I couldn't make any heads or tails out of the markings. They were worn off, so I couldn't really read the little dots down here. So let's look at it at 150 volts, and we test for leakage. Okay, that looks good. Now watch this. I go to 250 and watch what happens. Oh, weirdness. It starts leaking, and it's kind of jumping around leaking too. It's not just regular leaking, it's jumping around leaking. Go back to 150. Try this again. And 150. The reason I keep, there you go. Even at 150, after it's been given a shot at 250, it starts getting a little bit jumpy. So I don't know if you can really make that out or not. You see it's kind of moving around, and that's at 150. So I said, let me replace that. Now, one thing you want to do though, before you just say, oh, replace the cap, it's bad. I had the other test cap here. I can't demonstrate it, but when that happens, the best thing to do is put another cap in the tester and make sure that your replacement cap tests well. So what I did was I made up 100. I say made up because I didn't have a 100 PF cap. I had to put two together. I took two 47 PFs, connected them in parallel to double the capacity, hooked it up, and made sure I didn't have any of that leakage at up to by 450 volts. So you want to make sure your test equipment's good, because it can mislead you sometimes. You got to make sure it's working. I mean, this thing could have been acting wacky or something wrong with this thing. So you take the replacement cap, you put it in, it tests great. So anyway, let me get this out of the way. And here you can see the replacement caps right here. Can you see that? And right, shoot, it's kind of hard. Well, it's two little Micas, two little 47 PFs. Kind of hard. There it is. That tube right there, put together in parallel. And that's that tube, that's that capacitor I was pointing at. And now we've got a good stable picture. And before, it was real sensitive to contrast. If you didn't have the contrast set right, loose sync. Now, well, that's extreme sync. And that's I can adjust the vertical. Hold on a minute. I think some of this retrace might have something to do with those leftover paper caps. But as you can see, it doesn't lose sync even from extreme settings of contrast, which is good. And I've had it turned on for probably an hour now, and it's rock solid. The horizontal locks right in. So clearly that was the culprit. So you can't trust these Mica caps, but I encourage you people out there who like to do this kind of stuff is learn a little bit about the circuits to find out what's going on, so you don't just shotgun. Because obviously, I guess I could have just gone through and replaced every single one of those little caps, and maybe they don't need to be replaced. I mean, I'm not a big fan of replacing stuff that works. I'll let it run for a long time to see if it acts up, but not to mention, I can understand replacing the caps if you're really concerned. I say, well, that one went bad, Dave. Maybe the rest of them will go bad, possibly. So there's a valid argument. Go ahead and replace them now, just to be extra safe. I mean, if I was doing this for somebody else, and I have done work for other people on their TVs, and I have to admit, when that happens, I'll typically replace every single capacitor, even these Micas, even in the IF strips, whatever, just to get the thing as reliable as possible, because I don't want them to bring it back to me, especially if it's somebody who isn't close by. I don't want him to have his best chance to get it working, have it stay working. So I understand that, but I still, just for your sake of information, it's a good thing to kind of learn what does what, which is really a really good reason to kind of do one cap, check it, see what happens, kind of teach yourself a little bit about the circuit. Not to mention, there's always a possibility at some point, even after you recap it, the TV could fail again. I mean, something could go wrong. Then what are you going to do? Recap it again? Or find the one infant mortality cap that actually went out on you, because you can diagnose and know where to look. Like I said, typically I would have used a scope here to find this. I would just look at that sync signal and see, make sure the composite going in was good, and make sure that this clipped sync signal would come out was good. If it wasn't, then I could focus it on the exact capacitor. But I took a educated guess, and I got lucky. I didn't have to get the scope out. Anyway, we're getting really close now. I still need to replace a couple of these caps in the brightness circuit, so I'll fool around with that later. I'm just getting kind of tired. But it's looking good. I think we're almost there. Hope you enjoyed it. Thanks again.